Hello guys, good evening. So sorry for the interruption. We had some technical issue because of which there was a bit chaos. And I appreciate all your patience that you have been cooperating with us by staying patiently all this time. So yes, it happens at times. So let's start the session again from the beginning so that who have freshly joined can know the complete concepts again. Okay. So as the last chapter was real numbers, the first chapter of us. So today our chapter is going to be chapter 2, real numbers. So, sorry, chapter 2, polynomials. So in chapter 2, polynomials, first and foremost, let's see what is going to be the weightage of this chapter in the board exams. Then we'll go for the prior topics of this chapter. So here you go with it. So the chapter weightage here you can see. So this is the weightage scheme that I've been showing you in the last class also. So here you can see that the weightage of this chapter is, first of all, this chapter is into the category of algebra. So in algebra, you have 4 parts: polynomials, linear equations, quadratic equations, and arithmetic progression, which gives a complete weightage of 20 marks. So on an average, we can consider the weightage of this chapter to be 5 to 6 marks. Okay, so this is going to be the weightage of this chapter. Now, fine, let's move further to understand more about this chapter. Here you have the basic topics of this chapter are, you have 3 topics in this chapter, starting with the introduction of what polynomials are, what are the other things related to polynomials. Moving further, we have geometrical meaning of zeros of polynomial. So this is another topic which talks about how a polynomial looks like when you put it on a graph paper, and what is the meaning of zeros in that particular graph. So all these things will be understanding in part 2 of this chapter. Moving further, the core topic of this chapter, or the most important topic of this chapter, you can even call it, which is relation between zeros and coefficients of a polynomial. So in every polynomial, you'll be having coefficients. You all are familiar with it. So apart from polynomial coefficients, you do even have zeros of a polynomial. So what are zeros of a polynomial and how is it related to coefficients is all about this topic. So if you see the weightage track, here you can see the highest scoring topic is 2.3. That is this one, the relation between the coefficients and zeros of the polynomial. So in this topic, you'll be getting the questions of MCQ type, very short answers, long answers. Even case studies are having a lot chances to occur in this topic. So why let's start. So first, I would like to see how many of you feel this chapter to be difficult. Please chat it to me in the chat box. I would like to see how many of you are comfortable with this chapter. If you are feeling it difficult, type D. If you feel this chapter to be easy, type E to me in the chat box. So here you go. Moving further, let's have a quick review of this topic. So here you can see the first and foremost, we will see what a polynomial is and what is its degree. So what is the degree of a polynomial? We will see now. Okay, fine. Here you go. Now, a polynomial is nothing but, it is also an algebraic expression, but the thing that an algebraic expression need to satisfy to be a polynomial is it should satisfy certain conditions of the power of the variables in it. So when you consider an expression p of x, which is given on the screen as a n x power n plus a n minus 1 x power minus 1, so on like this till a1x and a naught, this is said to be a polynomial. This is an algebraic expression. All of you are familiar that this is an algebraic expression. But it becomes a polynomial when all the coefficients are, all the constants used for variable forms here are real numbers, and the power of the variable is a non-negative integer. That is, the power of x in this polynomial, whatever the term it could be there, the power of x should be either positive or it should be a power 0. Should never have a negative power for the variable. Then such an algebraic expression is said to be a polynomial. It's as simple. For example, if I write 1 by x plus x square minus 6. So is this algebraic expression a polynomial? No. Why? I can write it as x power minus 1 plus x square minus 6. So this is an algebraic expression, but it is not a polynomial because one term of it has a negative power for the variable n. So for that reason, this cannot be a polynomial. Clear? So this is the basic meaning of what polynomial is. Now here are some examples. Here you can see 2x power 4 plus 5x square minus 1. So here if you observe carefully, x is having a power 4 and 2. And here it is a constant, so it has no power for x. That is, you can consider as x power 0. So all of these are positive or whole powers. So this is a polynomial. Here also you can see y cube minus 0.7 y square minus root 2. So this is again a polynomial. And you may ask me, ma'am, root 2 is there. It is a constant term. And here 0.7 is a quotient of y square. And here y cube quotient is 1. Which all here 1 minus 0.7 and root 2 minus root 2. All of these are real numbers. So still it is all of these are coefficients. So which are real numbers? So coefficients can be real numbers. It could be anything. So for that reason, this is also a polynomial. Now moving further, here you can see degree of a polynomial. So whenever a polynomial is using only one variable, the polynomial can contain any number of variables, x, y, z, any number of variables. But we are specifically talking about one variable polynomial. And the highest power of the variable in it is called as degree of the polynomial. So here you can see, this is a polynomial in one variable x. And here the highest power of x, 4, 2, 5, and power 1. So among this, the highest power is 5. So the degree of this polynomial is 5. Now, the degree of a non-zero constant polynomial. So when I'm talking about a constant polynomial, like 5, if I write 5, this is also a constant. We can even call it as constant polynomial. Why? I can write it as 5 into x power 0. If I have minus 1 by 2, I can write it as minus 1 by 2 into y power 0. So all these are constants. These all come under the category of constant polynomials, but are the specific case with a non-zero constant polynomial. Even 0 is also a constant polynomial. But this is a special category in the constant polynomial, which we call it as zero polynomial. So here, for any non-zero polynomial, the degree is said to be 0. So in this case. But for zero polynomial, the degree is undefined. Why? Because 0 can have with a product of x power 5, 0 can have with a product of x power 50 or 10, whatever it is. So you can't define the degree once the polynomial is a zero polynomial. For that reason, this is an undefined case. Now moving to linear polynomial. What is a linear polynomial? A polynomial which is in the form of ax plus b. So here all of you can see ax plus b is a polynomial. Obviously a and b are real numbers. And here you should see that the coefficient of x should be a non-zero. Why should the coefficient should be a non-zero? Because if you make this coefficient 0, this term vanishes. Now it is nowhere linear polynomial. So if the degree of a polynomial is 1 in one variable, then you call it as a linear polynomial. Similarly, further you have here some examples of the same. 2 minus 3x, x by 4 plus 5, all these are polynomials in linear form. Now, quadratic polynomial. Just now I said, linear polynomial is a polynomial with degree 1. Whereas, if the degree is 2 for the polynomial, then we call it as quadratic polynomial. And the general form of a quadratic polynomial is this. This is very important to remember, all of you. So I'll just mark it again. So the general form of a quadratic polynomial is ax square plus bx plus c, where a is not equals to 0. So this is the important thing to remember. Okay. So let's move further to see the other type of polynomials. Here we have polynomial and its degree. In this second category, we have a cubic polynomial. So polynomial with degree 1 is a linear polynomial. Polynomial with degree 2 is a quadratic polynomial. Polynomial with degree 3 is a cubic polynomial. So here you can see this is the general form of a cubic polynomial where the highest power of the variable in it is 3. So let's move further. Here are some examples of cubic polynomials. The number of terms in a cubic polynomial need not be 4 always. It could be less than that also. Excuse. Now coming to the actual concept of the chapter. All this was a quick recap about polynomials. Now here we see geometric meaning of zeros of a polynomial. What is the meaning of zeros of a polynomial? You would be studying it in class 9 also. So the value of the variable for which the polynomial becomes 0. Now, for example, I have a polynomial called x minus 5. This is a polynomial. Now, for what value of x this becomes 0? Now, if I replace x value as 5 in this, I will see that p of 5 will become 5 minus 5, which is 0. So here, x is equals to 5 is said to be 0 of the polynomial. What do we call it? 0 of the polynomial. So now there is a geometrical meaning of the zeros. That means when you make the graph of any polynomial, you can identify its zeros by a certain observation. What is that here? So the geometrically, the zeros of the polynomial are the x coordinates of the point where the graph intersects the x-axis. Now, whatever the graph I have. Now, for example, just now I wrote x minus 5 is my, what do you call, a polynomial. Now, this polynomial, where will it intersect x-axis? So, it will intersect x-axis at x is equals to 5. This is the polynomial p of x is equals to x minus 5. So, at the point 5, 0, this graph will intersect the x-axis. So, you can say that the 0 of this polynomial is the x coordinate of this point, which is 5. So the x coordinate of this point is 5. So 5 is the 0 of this polynomial. So it's as simple as that. Whatever polynomial you have, just look at its graph. Where is it cutting the x-axis? Now the graph may cut x-axis somewhere here. The graph may cut x-axis somewhere like this. So wherever the graph is cutting x-axis, your purpose is to see where is it cutting. In all those points, what is the x coordinate you should pick? Obviously, y coordinate is going to be 0 because it is on x-axis. So the x coordinate of this point is nothing but 0 of your polynomial. Now the question arises, how many zeros will be there? It depends on how many places that curve is cutting the, or the graph of that polynomial is cutting the x-axis. So here is an example for the same. So see, there is a graph here, which is named as P of x. And this graph is intersecting x-axis at 3 points. 1, 2, and 3. What are the coordinates of these points? 3, 0, minus 2, 0, minus 4, 0. So obviously it is intersecting x-axis at 3 points. And it is intersecting y-axis also at a point. Where is it intersecting y-axis? It is intersecting at 0, 3. This is not needed for us because our intersection should be only with the x-axis. Now the x-coordinates of this are minus 4, minus 2, and 3. So the zeros of this polynomial, whichever p of x is there, its zeros are minus 4, minus 2, and 3. Okay, so this is how we understand the zeros just by looking at the graph of the given polynomial. Hope all of you are able to follow. Anybody, any doubts, you can ask, post it to me in the chat box. So let's move further. Now, We have been studying zeros is nothing but where the graph is cutting x-axis. Now, at how many places will it cut the x-axis? Depends on what type of polynomial it is. Now, if a polynomial is a linear polynomial, then how many places will it cut the x-axis? How many zeros will it have? Let's have a look. So the graph of a linear polynomial, which we generally call it as ax plus b. Now, the graph of it is just always a straight line. Any linear polynomial, if you make out a graph of it, it will be a straight line always. And the point where it cuts the x-axis is going to be minus b by a and 0. This will be the ordered pair of the point where it cuts the x-axis. And the x-coordinate of it is nothing but minus b by a. So this is the 0 of the linear polynomial. So here you can see you have a graph. This is a linear graph. And this graph is cutting the x-axis at a point A. So here at this point A, whatever your x-coordinate is, now for suppose it is x comma 0. Now the 0 of this polynomial is going to be this one. Now if you consider the equation, the polynomial graph is being given with an expression ax plus b, then this point is going to be minus b by a comma 0. So what is the 0 of this polynomial? Minus b. Okay. Now if the polynomial is quadratic polynomial, what happens? Now, just now we have studied the general form, which is ax square plus bx plus c. Now, whenever you draw the graph of a quadratic polynomial, it is a parabola. So, parabola is nothing but a curve which will be in the shape of something u. Either it could be top open, bottom open, left open, right open. There are many cases. But as per class 10, you'll be having top or bottom open only parabola. So what is a parabola and how will it look like? Let's have a look. So the first case, when the graph P of x cut the x-axis at two distinct points, then the x-coordinates of these points are zeros of the quadratic. So see here, this is a graph of a parabola. Now you have a quadratic polynomial. Now for suppose your quadratic polynomial is P of x. Now if this quadratic polynomial is making a parabola cutting x-axis at two different points, a dash and a, then the respective x-coordinates will be the zeros of this. Sometimes the parabola of given polynomial will be downward open. When will it be upward open? When will it be downward open? So that happens depending upon the a value, that is x square coefficient. Now, for suppose if you have a polynomial called x square minus 5x plus 6. So here you can see x square coefficient, which is a, is greater than 0, which is a positive value. Then your graph looks like this. Now, for suppose if the same equation is something like this, what can I say? Minus 4x square plus 4x minus 1. If your graph is like this, here you can see x square coefficient is negative. Then your parabola, which you draw for this polynomial, will be a downward open. Whether the polynomial is making a graph of upward open or downward open, no matter what, children. Simple point that you need to remember. The things why am I showing different graphs is in my exam, you may get different graphs. You shouldn't confuse whether, okay, the graph is opened outward, the graph is opened downward. So what will the values change? So to avoid that confusion, I'm telling you. So the simple thing always remember, whenever it is a quadratic polynomial, the graph is a polynomial. Irrespective of the coefficient of x square, see at how many points is it cutting the x-axis. If it is cutting the x-axis at 2 points, you are having 2 zeros. If it is cutting the x-axis at 1 point, you have 1 0. If it is cutting at x-axis at no point, you have no zeros. So maximum you can have 2 zeros. Why? The degree of it is 2 for that reason. So this is the first case where it cuts the x-axis at 2 different points to get 2 zeros. Now, there will be some situations where you'll be getting only 1 0 also. So, if your parabola is cutting x-axis only at one point, or it is touching also, you can say. It is touching x-axis at one point, or it is intersecting, or it is coming in contact with x-axis at one point. Whatever the case it is, in such case, you will get only 1 0. Now, you may ask me, ma'am, since it is a quadratic polynomial, it should have 2 zeros. Why is it having only 1 0? If at all, if such case is arising, the 2 zeros will be the same thing. Now, for example, if we have a quadratic polynomial called x square minus 6x plus 9. So if you draw the parabola of this, it will touch the x-axis at only one point because this is the standard form of x minus 3 whole square. So both its zeros are 3 and 3. So that is why it touches the graph at x-axis at only 1. So this is the scenario where such things happen. And the last case is when a quadratic polynomial has no zeros. That is, it will not come in contact with the x-axis. In this case, we say there are no zeros. These also do happen. Okay. So whenever such situations is happening, where you find that, what do you call, like if you have an equation, I mean, if you have a polynomial like this, x square, let's say minus x plus 9. So this is a quadratic polynomial. Again, you can see either here, it could be upward or downward, whatever it is. But if you draw the graph of this one example, which I'm showing on the screen, if you draw the graph of it, it will not touch the x-axis at any point. In such cases, you say that it has a no zeros. We will study in deep about all this in the quadratic equations chapter. Moving further, relation between zeros and coefficients. This is the third topic of this chapter, as I've said. The core important topic, maximum of your questions from this chapter is going to be on this one. So let's have a quick study on this. Whenever you find a linear polynomial, the relation between the zeros and coefficients, just now I said, ax plus b is the standard form of a linear polynomial. Now, if you equate this ax plus b equals to 0, you will get x is equals to minus b by a. So minus b by a is the value of x for which this polynomial becomes 0. So 0 of a linear polynomial ax plus b is nothing but its constant term divided by its x coefficient followed by a minus sign. I mean, preceded by a minus sign. Now, for example, if I have a polynomial like this, 2x minus 5. This is my polynomial. Now, if I draw the graph of this, where will it cut the x-axis? It will cut the x-axis at 5 by 2, 0. So how did I instantly say? The simple thing is the constant value, whatever is there, minus 5, that I should divide with x coefficient 2 with a minus sign before it. So it divides at 5, 2. See? 0 is nothing but the x coordinate of the point where it cuts the x-axis. So without drawing the graph, without looking at the point, directly just looking at the polynomial, we can calculate its 0. How are we calculating? By using the constant and the coefficients in it. So this is what all about the relation between zeros and coefficients of polynomial. Clear? Since it's a linear polynomial, it will have only 1 0, and we can get it easily by this one. So make a note of it. Moving further, you have a quadratic polynomial. So when a quadratic polynomial is given, obviously it will have 2 zeros. All of you know that. Now, if you consider alpha and beta are the zeros of it, now you can remember sum of zeros if you want. Sum of zeros if you want, you can do the coefficient of x by coefficient of x square. Now here, what is the coefficient of x? In this case, it is, okay, coefficient of x is b by coefficient of x square is a. So this is sum of zeros. And product of zeros is constant term divided by x square. So the sum and product of zeros of a quadratic polynomial. You have 2 zeros, alpha and beta. Now, if the graph is being drawn like this, and it is cutting the x-axis at alpha comma 0 and beta comma 0. Now you get the two zeros. What are the zeros that we have in this case? Alpha and beta. Now these alpha and beta, whatever values are there, how are they related with the coefficients? The sum of this alpha beta, if you do, this is nothing but minus b by a. And the product of this alpha and beta, if you do, you'll get it is c by a. Are you all able to follow me? Type Y in the chat box if it is yes. Type N if it is a no. Very good. Good to see that. Now, the last but not the least, if a polynomial is a cubic polynomial. So this is the last category where you get relation between zeros and coefficients. First we studied linear, then we went to quadratic. Now we go for cubic. So when it is a cubic polynomial, you have three zeros obviously because it has a degree 3. So it's obviously three zeros. Let that three zeros be here. You can see, let that be as alpha, beta, and gamma. And your cubic polynomial is ax cube plus bx square plus cx plus d. That is obviously whatever the graph you get. So it will cut the x-axis at 3 points. 1, 2, 3. Okay, I've just made some. So it's cutting the x-axis at 3 points. So let the 3 points be alpha comma 0, beta comma 0, and gamma comma 0. So these are the 3 points where it. So obviously alpha, beta, 0, gamma are its zeros. Now, how is it related with this A, B, C, D? Let's have a look at it. So the sum of zeros, that is alpha plus beta plus gamma, is nothing but minus of x square coefficient by x cube coefficient, which is nothing but minus. Since there are three zeros, you have taken each of them and added. Now we can take the product of two coefficients, two zeros like alpha, beta, beta, gamma, alpha, gamma. Now, such products sum, if you see, that is nothing but x coefficient by x cube coefficient. That is t by. Now, if you consider all the three zeros as a product, alpha, beta, gamma is minus d by a. Okay, you'll have the relation between the zeros and the coefficients of a cubic polynomial like this. So here you can see x square quotient and x cube quotient. If you divide and receive by a minus sign, it is sum of zeros. And two zeros taken at a time producted with sum of it is nothing but x coefficient by x cube coefficient. All the three zeros made a product is nothing but minus of constant term by coefficient of x cube. So this is as simple as that. Now, there are cases. Now, equation will be given. They'll ask you what is sum of zeros, what is product of zeros. Depending on, polynomial will be given. They'll be asking sum of zeros, product of zeros. By using those coefficients and constant terms, you can calculate. Just now we have studied all this. Now, what if you are supposed to find the zeros of a polynomial? Now, for suppose you have a quadratic polynomial, ax square plus bx plus c. You have. Now, if you want the sum of zeros, you get it as minus b by a. If you want the product of product of zeros, you get c by a. But I'm not individually getting alpha and beta separate. I'm getting alpha plus beta value, alpha beta value. I'm not getting separately alpha and beta values individually. So for that reason, there is another method to do. Of course, you can simplify this also, but there is another method to do. What is it? Is equate the polynomial to 0 and factorize it. You know how to factorize a quadratic polynomial. You know how to factorize a cubic polynomial. In class 9, you will be learning. Finding the factors of a quadratic polynomial and cubic polynomial. So once you factorize it, equate that each of the factors to 0. So all of those variables will give you a different value. Now you have a quadratic polynomial for suppose like this. You call it as say x square minus 7x plus 12. Now if I want to find the zero of it, If I find alpha plus beta, I will get it as 7 by 1, which is 7. If I do alpha beta, I will get it as 12 by 1, which is 12. But I don't want the sum and product of it. I just want what is alpha, what is beta. For that, what will I do? First, I will factorize it, which is x minus 4 into x minus 3. Now I will equate this to zeros. So x minus 4 into 0, x minus 4 into x minus 3 is 0. So obviously I get x value as 4, 3. So now see, these are the two zeros, which we can call it as alpha, beta. See, now the sum is 4 plus 3, 7. The product is 4 into 3, 12. I see. So this method of factorizing you would have learned in class 9. So whatever it is, either it is quadratic or cubic, first factorize it, equate each of it to 0, you will get the 0. Now, there is another most interesting topic where you can find maximum questions. Symmetric function of zeros of a quadratic polynomial. This is a subtopic of 2.3. In the 2.3, this subtopic is more important than the rest what we have studied. What is the symmetric function is? Now, first suppose alpha and beta are zeros of a quadratic polynomial. This symmetric functions we basically study for quadratic term. Be careful. This concept of symmetric functions is applied only for quadratic polynomials. So here, if you have a quadratic polynomial ax square plus bx plus c, and alpha and beta are its zeros, now an algebraic expression in alpha beta remains unchanged when alpha beta are interchanged. This is known as symmetric function of alpha. What is this? Let's study in detail. Now, what is the meaning of symmetric function in alpha beta? Means here you can see. Now, I'm talking about an equation whose zeros are alpha, beta. Okay. I know how to find alpha plus beta. I know how to find alpha, beta. Now, there will be certain other polynomials existing which will have relation with the zeros. How? Alpha square plus beta square can be derived from alpha, beta. Because whenever I'm talking alpha, beta, since it is a quadratic polynomial, I have alpha plus beta with me and alpha, beta also with me. Using this both, I can derive alpha square plus beta square. I can find the value of 1 by alpha plus 1 by beta. I can find the value of alpha by beta plus beta by alpha. Likewise, all these are symmetric functions of alpha, beta. Why? Because all these are derived from this 2k. Now, using this, I can make up new quadratic polynomials whose sum and product of roots are again. Now, if you want to know how to derive these values from alpha plus beta and alpha beta, here are some standard rules or identities that we use. So here you go with it. So if you want alpha square plus beta square, how can I derive it? Alpha plus beta whole square I can do minus 2 alpha. So see, sum of zeros I will square and I'll subtract twice the product of zeros to get alpha square plus beta. Similarly, if I want the other one, 1 by alpha plus 1 by beta. So see, sum of zeros by product of zeros I will divide. So I want to find alpha cube plus beta cube. So this is again another identity. In class 9, you'll be learning the cubing identity. So from that, we will derive the third case. Okay. So any doubts? So shall we go for questions? Okay, here we start. Weightage as per how you write a solution. Now we have seen chapter, we have seen what are its topics, we have gone through the quick review of all those topics. Now at the end, what all you have learned in a topic is being seen in how you write your answer, how you describe your answer. If it is a 1 marker, no issue, your answer is only valid. If it is more than a 1 marker, steps of your solution is obviously valid. In that case, what can we do? Let's have an example. Here is a question. Alpha and beta are the roots or zeros of 4x square minus x minus 4. This is a quadratic polynomial. Its alpha and beta are given. Now, alpha and beta are its zeros. Now I have to find a quadratic polynomial whose zeros are 1 by 2 alpha and 1 by 2 beta. Let me explain it first of all. Now, if I want to find a quadratic polynomial whose roots are this, it is very easy if I find the sum of these roots and the product of these roots. If I find, I can get the polynomial. But how can I find this? First of all, I should know what is 1 by 2 alpha plus 1 by 2 beta. What is 1 by 2 alpha into 1 by 2. For this, I will find alpha plus beta values. Now, my polynomial which is given here is 4x square minus x minus 4. From this, what is my alpha beta? Alpha beta is minus b by a, which is equals to here b is minus 1. So minus of minus 1 by 4, which is 1 by 4. What is my alpha beta? Alpha beta is c by a, which is minus 4 by 4, which is minus 1. Now I have alpha plus beta with me. I have alpha beta. I have to find 1 by 2 alpha plus 1 by 2 beta. I have to find 1 by 2 alpha into 1 by 2 beta. So how will I do that? Let's do it one after the other. So here I want 1 by 2 alpha plus 1 by 2 beta. So if I make the LCM, this is alpha plus beta by 2 alpha beta. So what is alpha plus beta value? 1 by 4. What is 2 times alpha beta value? Minus 1, which is minus 1 by 8. Same way, I want to find 1 by 2 alpha into 1 by 2 beta. So which is nothing but 1 by 4 alpha beta. I will get it as 1 by 4 into minus 1, which is nothing but minus 1 by 4. Now I have sum of roots of my required equation, sum of zeros of my required equation, product of zeros of my required polynomial. In that case, how will I find the polynomial? As usual. So my polynomial is going to be x square minus of alpha plus beta into x, because sum of roots plus product of roots will be applied. So for this completely, I am multiplying with k because it is a polynomial. It can have whatever the coefficients is, but proportionate coefficients are applied. So now if I apply it and solve it, I have no space. So let's show you the solution. So here is it. See here. This is the polynomial that I get. See, I have started first finding my what is alpha plus beta and alpha. Now using these two values, I am finding the new polynomials, sum of zeros and product of zeros. How? Minus 1 by 8, product of zeros minus 1. Like this. Now if I want a new polynomial, how will it be? It will be k times x square minus of sum of roots plus product. So k times x square minus x by 8 minus 1 by 4. If you solve it, you'll get it. You can ask me, where did this k go? Since k is an arbitrary constant, you can exclude. Because I already have a denominator, so I applied that denominator to that k and I have excluded. Now, if you solve this question, suppose if it is a short answer question, how are you being marked for this? What is your foremost core concept? You have to find a new equation. For the new equation, you want sum of roots, product of roots. That you should derive from what is given. So from what is given, if you find alpha beta and alpha plus beta values, you will get 1 mark for that. There. Because you are able to visualize for what you need, what you should start with. So you have started with alpha plus beta and alpha beta, so that part gives you 1. Next, you are supposed to find the sum of zeros and product of zeros. So each of it will give you half and half. Later, you got your sum of zeros and product of zeros. You're supposed to replace it in the required equation to simplify your equation in a simplest. For this again, you get 1. So this is how your 3 marks of your question is being segregated for a solution. Yes, perfect. Right answers. Okay. Anybody, any doubts? You can ask me. If you have no doubts, I'll move further. Now let's see one more question of the same pattern. Here you have 1 0 of a polynomial is a reciprocal of the other. There are 2 zeros because it is a quadratic polynomial. It's clearly seen. Here all of you can see it is a quadratic polynomial. So since it is a quadratic polynomial, it will have 2 zeros. Let the 2 zeros be alpha and beta. But I'm not taking it as alpha and beta. Why? They said 1 0 is the reciprocal of other. So if 1 0 is alpha, the other 0 is going to be 1 by alpha. Now, the sum of these alpha and 1 by alpha makes me no sense because I have to find the k value. Then alpha plus 1 by alpha, I'll get minus b by a form, which is not solving me for k. But if I find the product of these zeros, I will get it as c by a. So alpha into 1 by alpha is 1. C by a here is minus of k minus 2 by 6. So now if I solve this, what will I get my k value? 2 minus k is equals to 6. So k is equals to minus 4. So as simple as this. So here, now for suppose if it is a very short answer, how are you supposed to do it? First and foremost, you should know to find the k value, you should use the constant. Using this zeros relation. Zeros relations are alpha and 1 by alpha here zeros. You have to relate it with the constant by means of their product. So you are able to identify the relation between what is given and what is asked. Later for solving, you will get one more half. Like this. Clear? So for analyzing and relating what is given and what is missing, half mark will be there. And for further solving, you'll get one more. Let's see one more question. Here is another question. This is again a pattern of question which you find it in the board exam. Alpha and beta are the roots of the zeros of the polynomial px square minus 2x plus 3. Here they said sum of zeros and product of zeros are same. And you are supposed to find the value of. Now, sum of zeros is same as product of zeros. Then what can I say? Minus b by a value is same as c by a value. So minus b by a is minus of minus 2 by p. And here you get 3p by p. So pp gets cancelled. You are getting 3p is equals to 2, which gives you p value as 2 by 3. So again, you are supposed to write the steps in this. Now, for suppose if it is a 1 marker, you are using the relation what is given to make a statement relating the coefficients for this half mark. And again, to solving for the value of p, you are getting 1. So writing answer exactly, getting an accurate answer, to what extent it is important, writing an appropriate steps is again important. So in this case, if it is an MCQ, it's clearly an option P. So you'll get P value as 1 by 2. So if it is an MCQ, you don't need to show the description. But if there are chances of such questions being occurring in very short answers, so you should know how to write it descriptively also. So we have given you the clear detailing of it. Now let's see one more thing. Form the quadratic polynomial whose sum and product of zeros are like this. Sum of zeros is also given. Product of zeros is also given. You have to form the polynomial. Now, if the sum of zeros of the polynomial is minus 3 and product of zeros is 2. So automatically, the sum value is given as minus 3 and product value is given as 2. So you'll get a polynomial k times x square of minus sum of x plus, which is nothing but x square minus of minus 3x plus 2. We get it as x square plus 3x plus 2 multiplied with an arbitrary constant left as it is. I'm not removing this k. Why? Because Even now, for suppose I have an equation a polynomial x square plus 3x plus 2. Now, for a polynomial 4x square plus 12x plus 8. For this polynomial also, sum of zeros is nothing but minus 3 and product of zeros is 2. Now understood? For x square plus 3x plus 2 also, I am getting the sum value as minus 3 and product of zeros as 2. Here, if the polynomial is 4x square plus 12x plus 8, still I am getting the same sum and product of 0. That is why this arbitrary constant says that if every term of the polynomial is multiplied by a constant value, so it doesn't affect the sum and product of zeros. For that reason, we put that K. So here you can see sum of zeros and product of zeros are given. And if you solve it, you'll get the equation. Polynomial like this. K times x square plus 3x plus 2. Now, if I consider K value as 1, this is one such situation. I've shown you one more example when I took K value as 3. So there are different polynomials satisfying this condition. One as such is when K value is 1, it becomes x square plus 3x plus 2. Clear? So now it's your question answer time. Let's see to what extent you have understood your chapter of polynomials so far. Okay, here you go with the first question. And this is an assertion and reasoning type question. So here are your 4 options. Read it carefully and send me your answers in the chat box. I don't think all are able to answer me directly. Are you all able to? I could see right answers so far. Very good. Perfect. And what about the others? There are many children in the class. I hope that you people could send me answers to my personal chat. Or if you're sending it to someone else, I would request you to send it to my. Okay, yes, the answers are absolutely right. It is option B. Why is it option B? You can clearly see that this is what in the introduction of polynomials I have been explaining you. Degree of a zero polynomial is undefined. So it is a true statement. And degree of a non-zero constant polynomial is 0 always. So these both are true statements. So this is a special category in constant polynomial. So exclusive cases of constant polynomial where it is 0 has an undefined degree. All the other cases it is 0. So obviously it is a clear answer that both A and R are true and R is not explaining A in any. So B is the option. Moving further, the next question is here to go solve it. Find the number of zeros in each of the following graphs. I'll be showing you graphs one after the other. You have to tell me how many zeros does these graphs have. So here is the first one. So how many zeros is this graph having? Now, the polynomial in this graph has how many zeros? Very good. Very good. Perfect. Perfect. Please do not send your answers in the public chat because whoever is trying, they may get even demotivated by looking at the other answers. So try to send your answers into my personal chat. Perfect. Yes, all the answers are right because it is meeting the x-axis at only 1 point. So it has only 1 zero. Perfect. The next graph is here. So how many zeros does this polynomial have? Perfect, perfect, very good. Quick and instinct answers. So yes, here it is intersecting x-axis at 3 different points. Here you can see 1, 2, and 3. So it has 3 zeros. Perfect to go. The next one. How many zeros does this have? Okay, this graph is directly giving you a hint. Where is it also? So you have no hard work to do with it. So it has 2 zeros, as you can see. The arrowheads are already showing you the answer, right answers. And how many zeros is this graph have? Very good, very good. Perfect. This graph has again only 1 0. Be careful. The other points where it is cutting is y-axis. You are supposed to look at only x-axis intersection. And the last graph is here too. So how many zeros is this having? Perfect. Excellent, excellent. It has no zeros. So it is not cutting x-axis at any place. So it has no zeros. So here are your pictures answers. First one is 1 0, next 3 zeros, 2 zeros, 1 0, and no zero. Here you go with the next question of today's chapter. Solve it and let me know the value of k. If this polynomial has sum of zeros, which is half, sorry, what is this? 1 second. Equal to. This is nothing but equal. Half of product of its zeros. So the relation between sum of zeros and product of zeros is like this. What will be the value of k is your question. Okay. Okay. I have different answers. Let's see who's going to be the right answer. No problem. You can take your time. I'll give you a minute more so that you can resolve it and send me. Okay. Fine. Let's see how to solve it. Now, what is the condition they said? Sum of zeros is equals to half of product of zeros. That is, alpha plus beta is nothing but 1 by 2 alpha. Now, what is alpha plus beta? Minus b by a. This is 1 by 2 into c by. So now let's see. Here you have minus b by a as 6 times k plus 6 by 1, which is equals to 1 by 2 into 2 times 2k minus 1 by 1. So obviously here you get 6k plus 36 is equals to 2k minus 1. Okay. So when you solve this further, 1 second. So what will you be getting? 4k is equals to minus 37. K equals to minus 37 by 4. That's it. Clear? Some of you have given me in decimals. It's okay if the answer is also in decimals. I'm okay with that. So here is the answer. Oh, sorry. It was a mistaken answer. Sorry. Let's exclude it. Let's move further. Here you go with. Here are the four options given. You have to find a quadratic polynomial whose sum of zeros is also given to you and product of zeros is also given to you. So this is again an MCQ type question where you can see you just need to replace -7 and 12 in the place of alpha plus beta and alpha beta. So where does it go? That you need to observe carefully. So perfect. It is option C. So why? Because sum of zeros, if you calculate it, x square minus of sum of zeros into x plus product of zeros you get. This is what the polynomial you get with whatever the values are given. So x square minus of -7 times x plus 12. So if you solve it, you'll get it as x square plus 7x plus 12, which is in option C. So C is the right. Okay. So C is the right answer. Let's see one more question. So here is a case study type question. So read it carefully because as I've said, this chapter has lot chances of getting case study questions in the topic of part 3, that is zeros relating or whatever it is. So here it is a case study question. Study it carefully and answer the question below. First and foremost, find the value of K. I think you have options. Yes, you have. A polynomial is given. This is how a parabola of a diver is represented. Like, I think all of you know diving. What is diving? The person is standing, Annie is a person who is standing at a height of 48 feet above the water level. And once she starts diving it, she moves upward and then comes downward, making it in the form of a parabola. Now, if the polynomial representing the parabola is given like this, and how is this parabola varying? So the person starts jumping and then he falls. So only things what is relating over there is time and height. So initially the person was at a height of 48 feet. Later after jumping, once 1 second, 2 seconds, 3 seconds, as the time is passing on, the height of the person is varying because he is in the motion of time. Now here the terms relating are height and the time. Now, using this concept of height and time, you're supposed to find the missing term k in the polynomial. Right answers. Let's see. How is it? So, first of all, what is the logic that we can use here is, I have the polynomial minus 16t square plus 8t plus k. Now, initially, when the person hasn't done any jump, that is at the time 0. So, the time was 0 seconds. Once the time was 0 seconds, height was 48 feet. So if you replace this point in this polynomial, what will you get? H of 0 is equals to minus 16 into 0 square plus 8 into 0 plus k. This is the initially at the time when was 0, the height of the person, height is nothing but 48. Now if you equate this, you can see k is equals to 48. So using the initial condition, when the person is ready to jump, she hasn't jumped. So using that logic, we are finding the k value as 40. Now we will see the next question. At what time she touches the water in the pool? Here are your options. Perfect. Very good. Can I give the answer? Now, again, we use the same relation of H and T. So once the person touches the water, automatically height is no more left, height becomes 0. And time is a missing factor that we need to find. Now, how will this polynomial change with the k value? It becomes minus 16t square plus 8t plus 48. And the height at the final stage once it touches the water is 0. So now you can remove the common factor that we have here, 8. If I take out minus 8 as common, I will have it as 2t square minus t minus 6 is equals to 0. So I have 2t square minus t minus 6 equals to 0. I have to solve this to get the t value. Now, as I've already said in the quick recap that if you want to find the zeros of given polynomial, automatically you have to factorize it. Once you factorize it, then you should equate each of the factor to 0. So if you factorize this here, you have 12 minus 12 as a product. So which is minus 4 and plus 3 are the two factors. The middle term splitting. So 2t into t minus 2 plus 3 into t minus 2 equals to 0. So if you solve it, t minus 2 is one factor, 2t plus 3 is the other factor. So you get t value as 2 and the other t value as minus 3 by 2. Here t is talking about time. Time can never be negative. So obviously, after 2 seconds, Annie will be touching the surface of the water in the pool. Now, let's see the last question of this case study. Here you go. Find the polynomial q of t whose sum of zeros is 1 and the product of zeros is minus 6. And this is being analyzing the modeling of the another person, Anu's height in the water level at the time of t. You have to find the polynomial. Here, sum of zeros, product of zeros are already given to you. Be careful, do not forget to use the constant k. And k value you should find out and replace it. And do not leave the class. Do stay back. You have a surprise at the end. So stay back, all of you. And I'll be revealing you the answers of the last session's chapter 1's practice questions also at the end. So do stay back. Yes, right answer. So let's see what could be the polynomial representing Anu's height in terms of a time. So here we will get the polynomial as k times sum of zeros is 1. So x square minus x and product of zeros is minus 6. Sorry, I'm supposed to write in terms of t. I forgot to write t. Okay. What will it be? K times t square minus t minus 6. Now this is the polynomial. In this polynomial, first I should find the k value. So how will I find the k value? So this is at height. We know that the height of the diving board is 48 feet. And initially the time is going to be obviously 0. So when time is 0, height is 40. I will use the same logic and apply it. K times 0 square minus 0 minus 6 is equals to 48. I solve it, minus 6k equals to 48, which gives me k value as minus 8. Now I'll replace in this polynomial, which is h of t is equals to minus 8 times t square minus t minus 6, which gives me answer of multiplying it later. Okay. So here you go with the whatever with the answer of it. Minus 8 times t square minus t plus 6. And the first two answers I've already said you, C and B. Okay. So here are the practice questions for this chapter today. And as I've been already suggesting you, I want all of you to timely practice the chapter soon after the revision because we hardly have 2 months of buffer time. First chapter is done. Hope all of you have practiced it. And this is the second chapter practice. And we have suggested you more materials also. Like we have suggested you score more, champion, 100% and all those things in the last class. So we always are at your step for clearing all your doubts, any queries. So you can ask your queries in the class at the end, or you can post it to us later to the concerned references. So, and here I go with a revision, the answers for the practice questions of the last chapter. Okay. So that's your session for today. So as said at the end, all of you would have been receiving a link in the chat box where you will be having a scope of solving sample papers for your practice. It will be uploaded through the link we provided to you. So do proper practice with that also. So that's for today. Let's meet in the next session on Friday with another chapter. Till then, bye. Stay safe and study well. Bye.
Yes, ma'am. You can share the next topic also so that we will be discussing in the class.
The next topic that we'll be discussing is already, I think I've shown it in the chapter 1, but if you just want it, I'll just show it again. So here you go.
Very beginning, you can see whoever want to make a note, you can see it's linear equations followed by quadratic equations, then arithmetic.
So the sequence is continuously, all the chapters continuously up to chapter 2, 3, 4, and 5. Okay, the next one is linear equations. Or you can even call it as scale of linear equations also. So that will be studying in the next chapter on Friday. Till then,
bye. Anybody have any queries to ask?
They can raise their hands. Okay, so ma'am, I think we can finish the session now.
Okay.
So, thank you so much. Thank you for joining. The next class at Friday at 4 p.m. and we will be having the next topic of the class. So stay tuned.